Okay. So anyway, here are the answers. This packet should be pretty simple. Like you're just adding the exponents in this case. Same thing over here. Same thing over here. However, you don't want to leave this as z negative 5. Whenever you have a negative exponent, it's usually advisable to put it in a fraction. So you do 1 over z5. You're not writing z negative 5, but it's just more of a formatting thing. Best to keep the exponents positive. This would be x negative 4, but 1 over x4. So you guys see I'm just like adding the exponents, right? When the powers, so x to the 5th, right? This whole thing is called the power. That whole thing's called the power. But more specifically, that's a base because it's in the bottom, like the basement of a building. Like we have a basement here, right? That's the bottom of the building here, right? And then exponent kind of sounds like extra, like it's kind of up above. So that's the exponent. But so I want to make sure you guys are cool in the terminology. The whole thing's called the power. The base is x, the exponent's 5. So when the bases are the same, like in the case of a, d, g, or h, and you're multiplying the two powers, you would add the exponents, right? So that's what I did for a, d, g, and h. Likewise for C and F. For C, you should get x squared, and for F, you should get y4. So hopefully that makes sense how those are done. Now, I is a little different. What are you going to do about I in this case? How are you going to combine those? Josephia? Yeah, subtract. Exactly. Subtract x to the 5th power. There we go, right? So you would subtract in that case. And the reason why you subtract is that you have 15 x's. I'm not going to write 15 x's, but kind of use your imagination. There are a lot of x's up top and a lot of x's down below, but only 10 x's. So a bunch of stuff cancel, leaving just 5 x's up top. That's why it's x to the 5th. Now, B and E are a little unique. You have to multiply the exponents in this case. You still do 2 squared, which I know is 4, but you can do x to the 6th power. So you get 4x6. And for E, you get 27x3. So hopefully that makes sense how those are done. We're okay? Okay, great. Let's keep on trucking here. More of the same stuff. I'm just going to kind of do it quickly. Y negative 6, which is 1 over y6. This is z8 then squared. So it becomes z16. Or you can strip it beforehand and add. Totally up to you. X is anything to the 0 power is always 1, just so you know. Does anyone know why when you raise something to the 0 power it's 1? Anyone have a good explanation? But my AP Calculus students sometimes don't know this, so I'm curious if anyone. I'll be really impressive. Anyone does know, but if you don't, that's fine too. Anyone know why? It's 1. When you raise them to the 0 power, why is the answer always 1? When you raise them to the 0 power. Here's the reason why. I'll give you a quick explanation. So what if you have 2 to the 5th power? What does that mean? 2 to the 5th power. What are you supposed to do? Exactly, right? But here's the thing that no one really tells you. There's actually an invisible 1. The 1 is invisible. It's there because anything times 1 is itself, right? I could write any number with a 1 next to it, right? Because 1 times itself is itself. So there's a 1 here all along. So now let's slowly reduce these exponents, right? If I make that 4, guess what? I have to erase one of the 2's, right? What if I now drop that down to a 3? So you count down, right? I got to erase another 2. What if I erase? What if I make that 2 now? I have to erase another 2. You guys see where I'm going with this? Yeah. What if I change that to a 1? And then finally, let's change that to a 0. And if you do that and erase that last 2, what are you stuck with? 1. That's why anything raised to the 0 power is always 1. That's the reason. So now you know. You might forget, but at least I feel like I told you. So now you know. Anyway, so that's going to be x to the 8th times 1 over x to the 12th. That's x to the negative 4 you have to subtract, and we write 1 over x4. For k, that's going to be w1, or w straight up. For m, that's b5 over b, which is b4. For p, you have y8 over y negative 1, and when you subtract those, you get y9. For q, you have negative 2 raised to the 3rd power, and then you have b. Actually, let me backtrack a little bit. You have negative 2 b6 raised to the 3rd power. Then you distribute, you get negative 2 to the 3rd power, b18, which of course is negative 8 b18. Here, you have 9x4. times 8x negative 6. That's 72 over x squared when you work all out, because you get negative 2, it should go on the bottom. And lastly, for O, you should have 3x4 times x3 over 27. That should reduce to x7 over 9. Okay, so we're okay? Come on, go. No, because there are no for Q or no negative numbers. Q, right? Yeah. The negative number is fine. The negative 2, that's not a problem. But yeah, you're right like that. Okay, cool. Let's move on to the new stuff, and I also got to take rolls. So let me do that really quickly. What was the question? Let me undo. It was 72 over x squared. And everyone's here got 4, 8, 10. We're missing somebody. Who are we missing? Who? Oh, that's right. Yeah, Gus Mendel. Right. Okay. Family trip. Okay. All right. Cool. All right. So let's now move on to the new stuff for today. Let me hand it out. So the plan, like usual, I'm going to try to give you guys time to work on homework today in class. I don't know when our next test will be. Figure that out. Yeah. Well, I dropped the fast game. It's again this weekend. Are you running back stuff?
Yeah. Are you drafting this weekend?
No, we are drafted.
Oh, yeah. First game.
Yes.
Yeah, because he watched. I feel like this is
okay. And Clay, I'm gonna have you join the table in the back so that you're working the group. Okay, let me pull up the classwork for today. Here we go. Okay, so this will seem a little confusing at first. So I'm going to do parts A and B with you guys to kind of at least model the process. And then part C and D, I'll probably have 2 groups do part C and 2 groups do part D, and the guys will compare your answers. I think that's how we'll do it. And just so you know, we're venturing to a new topic called exponential functions. Exponential takes on this form, y equals b to the x. That's called an exponential function, just so you know. You may want to write that down somewhere. So that's an exponential function where b is your base and x is your exponent. And just so you know, the base could be bigger than 1 or between 0 and 1, but never inclusive and never negative. I'll explain why as we get through this. When b is bigger than 1, we're going to call this growth. When b is between 0, we're going to call it decay. A great real-life example to help you understand exponential functions, think about COVID 3 years ago, right? COVID counts were rising. Unfortunately, death rates were rising too. That used an exponential model, right? Because you would see a sharp increase, right? And of course, then we talk about the flattening of the curve. That's another story. I'll talk about that later. But that's a great example of exponential growth that we saw in the news daily, right, during the pandemic. And that was a toy example of growth, right? But anyway, let's talk about the story here. Can I erase this stuff I wrote? We're good? Okay. All right. Do you guys still read of Mice and Men? No? Is that freshman literature? No? Okay, when I was a freshman, we had to read it like 30 years ago. Actually, 32 years ago for me. But anyway, in the book of Mice and Men by John Steinbeck, 2 good friends named Lenny and George dream of raising rabbits and living off the land. What if their dream came true? Okay. And as you can imagine, rabbits reproduce very quickly, right? Like if you go to the farm over here, we constantly have rabbits, right? They have a small gestation rate, so they just reproduce like crazy. Work with your team to come up to investigate one scenario from below. I'm going to work with you guys for the first two, so don't worry about that for now. Your teacher will assign a scenario to your team. That it will do. We will do multiple representations, table, graph, equation to represent each scenario, and then be prepared to share it with me when I come around and check on you. I'm going to do parts A and B with you guys first, just to make sure you guys understand what to do. So I'm going to have one person read part A. And Pierce, since you're talking, why don't you read part A?
Suppose Lenny and George started with 2 rabbits.
Mhm.
And each one following those rabbits have 2 babies. Also suppose that Henry and thereafter each pair of rabbits has 2 babies.
Okay, great. So let's do a table first. This is gonna be a little confusing, but let's do a table first. Okay. So we're gonna do this. I'm gonna make a T table. We have X and Y. And this is the hard part. This is why people struggle.
But it shouldn't be the hardest part. But we need to always do this, right? That's why it shouldn't be the hardest part. But people do struggle with it. We got to figure out X and Y represents, right? We got to figure out the represent. So we're interested in number of rabbits, obviously, right? What's the other variable that we need to play around with? The month, time, totally, perfect.
Yes. So we'll let X be the number of months. And let Y be the number of rabbits. So whenever you're dealing with a scenario that you're not really sure how to make sense of it, make a table. But even more important, and Jack, you're wearing an Eagles shirt? You're an Eagles fan? Yeah, you failed the class. You're done. Just leave. Sorry, I'm a Niners fan. It's okay. Well, you won one Super Bowl. Just one. You won 5. Okay. Anyway, sorry. Okay. I'll give you a hard time later in the year. Okay. Now let's get back to math. Sorry. All right. So month 0. How many rabbits do we start with, guys? 2. So month 0, we have 2 rabbits. Now, month number 1. How many rabbits do you think we have now? So you have 2 rabbits. You have a male and a female, right? Just to say if you have male, female. How many rabbits are you gonna have after 1 month? 4, right? Because they make babies and have 2 rabbits, right? Okay. Now this part's a little tricky. What do you think is going to be after 2 months? What do you think we're gonna have? What do you guys think? I would say 8, and here's the reason why. They said that each pair has 2 babies. 4 rabbits is 2 pairs, right? So you have pair 1 and pair number 2. So guess what? Pair number 1 has 2 babies. Pair number 2 has 2 babies.
And yet 4 previously, right? So 4 plus 4 is 8.
Okay. Let's do just a couple more, just so we get a sense of the pattern here. And it's all about pattern recognition, guys. All about pattern recognition. So now month 3. 16. So what's the pattern, guys? It doubles, yes. So the pattern each month. Now, of course, rabbits die. We kill and cook them too. I know, sad. Or maybe a fox comes and kills it. Who knows, right? But assuming that they, for a while, they don't die, this is what we expect to happen, right? Okay, so we now represented this numerically, right? We have a table. Now, next up, we're going to do a graph. Let's do a graph. I'll do a graph down here. Let's go red. So what's the x-axis again? Yeah, or time, whatever you want to call it. Time in months. And of course, y is going to be rabbits. Number of rabbits. Okay, and then I'll just do this 0, 1, 2, 3. and what the heck will do 4. And this gets a little tricky, but I might need to make this a little taller. That's why I give you guys big graph paper for the work today. We'll do like 5, 10, 15, 20, 25, 30, and so forth. So you kind of want to equally space it out. So at 0, we had 2, right? At 1, we had 4. At 2, we had 8. At 3, we had 16. At 4, we had 32. And the curve will look like this. And obviously not going to put negative numbers
because you don't have time machine. You're not going backwards in time. You're going forward in time.
So that's generally how the curve would look. It's going to usually be a pretty sharp increase. That when we hear things increasing exponentially, that means things are increasing very fast, right? That's usually how we use that term. And then lastly, an equation. The equation is going to be a little tricky, but I think you guys can. So we looked at things numerically, table. We looked at things graphically, right? The graph. Finally, an equation. So that's what we have you guys work on. We're going to do a table, do a graph, do an equation. So what do you think the equation would be? Y equals what? 2 to the x power? Are you sure? Well, let's just start with that one. 2 to the x won't work, obviously, right?
So I pointed 0. Almost 2.
You could do +2, but then you're going to run into another problem, right? Because if you plug in 0, you can actually get 3, right? So, Evie, you have an idea? Yeah, you're close. You're going to start with 2. 2 times 2 to the x power. You're going to do 2 times 2 to the x power because you start with 2. This is what you start with. And this is the rate. At what rate does it increase? It doubles, right? So you need a doubling. You need to keep doubling over and over and over again. So that's where you start. And the other 2 is going to be the rate. You could actually combine them. Because 2 by itself is 2 to 1 power. How would I combine those exponents? 2 to what power? No, you don't multiply the bases. You add the exponents, right? So you can also write like that too. Either way works. 2 to the 1 plus x or 2 times 2 to the x power. Another thing to keep in mind too, which you could do somewhere in the margins. Remember I told you this formula y equals b to the x? I kind of lied because there's more to it. It actually should be this, y equals a times b to the x. Because a is going to be your initial value. And b is what we call the growth factor. Because this thing is growing, right? It's getting bigger. And how is it getting bigger? You multiply by 2. If you multiply by 3, make it 3. Multiply by 4, make it 4, and so forth. It can also be called a decay factor if you're dropping. We'll talk about that later. But that's what you're going to do. So we're going to do another one. I'm sure you guys probably have questions. You probably still maybe kind of get, maybe don't. I don't know. Any questions, though, just in general, before I move on to part B? Okay, let's try another one. I'm going to do the same thing. Table, graph, equation. And then I'll have you guys try C and D. All right, so let's move on to B. Now, they started with 10 rabbits, okay? And each pair has 2 babies, same like before, right? And every month, each pair has 2 babies, okay? So let's do a table again. So month 0, we have 10, right? After month 1, what do we have now? Davis, go ahead. Oh, sure, yeah, totally. So, yes, if you're not good. Well, each pair, you have 5 pairs. Yeah, you have 5 pairs, right? And each pair has 2, so 5 times 2, so it'll be 20, yes, exactly. No worries, no worries. So 1 month, 20 babies, right? So it's going to still keep doubling. and so forth.
So just by introducing a few more rabbits,
at 3 months, we have 80. That's a lot, right? There's a lot of rabbits going on. We start having a population issue. Okay, graphically, here's how I do it. 1, 2, 3, 0. Let's do this in scales of 20, 10, sorry. Sorry, my handwriting is really ugly. Okay. So we're starting with 10. Then we have 20. Then you have 40. Then you have 80. See, it still follows the same shape.
but very important that you label the axes appropriately. So when I like actually score this like on a homework quiz or on a test, I'm really looking at how you label this. And of course, the general shape of the graph has to be flat.
I'm looking for how you label too. And then finally, the equation. What do we start with again? How many rabbits to start with? 10. And how at what rate is it growing at? 2. And you leave ramps like this. Now, please, 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 please don't do this. Never ever do this. This is actually one of my biggest pet peeves as a math teacher. I don't know why, it just bugs me. Do you guys see what's wrong with what I just wrote?
What did I do wrong? Well, first, what did I do? I multiplied 2 and 10. Can I do that? And no. Well, of course, I asked that question. Okay, but why can I not do that? Why is that bad?
To the ends.
Yeah, it's PEMDAS, right? What comes first, multiplication or exponents? Exponent. So I don't know what x is, so I gotta hold off on multiplying 10 to 2 to the x until I know what x is. Once I know what x is, I'll plug it in, I'll do 2 to that power, then I'll multiply by 10 afterwards. Do not bypass the word of operations. That's really bad. Really, really bad. Don't do it.
Never ever do that. Okay, yes.
How would you write out in like the y equals 2, 1%?
You can't. Great question. That is a fantastic question, dude. How can I combine them? You can't, unfortunately. You can't. Yes, we had that luxury before. And actually, I'm so glad you brought that up because part A, we had this, right? And fortunately, the bases were the same. So I had that luxury of combining them and making it like this. You didn't have to come if you didn't want to, but you could. Unfortunately, these bases are different. Nothing you can do about it. 2 to some powers, like to a decimal power, could be 10, like 2 to maybe the 3 point whatever power. But I don't know this off the top of my head. Now, what if this were an 8, for example? What if I had an 8 here? Then you could combine them, but you have to change 8 to 2 cubed first. And then you can do 2 to 3 plus x. At that point, you could do that, as long as the bases are the same, right? But unfortunately, the 10, yeah, great question, though. Yeah, so personally, just leave it as the initial value times the power. Okay, cool. So now what we have you guys do is try C and D. Actually, I'm going to have everyone do C and D. Everyone do C and D. I'll come around and help you guys out. So they start with 2 rabbits. So this is A. And then each one follows this, they have 4 babies. Okay, so you're going to need to figure out what to do there. And then here, you start 2 rabbits. That's your A value. And then 6 babies. So what I want you to do is make a table. I say do 0, 1, 2, 3. Okay. Do a graph. So table, graph, and then equation. And the equation is generally going to look like this: y equals a times b to the x. So a is going to equal 2 here, and a is going to equal 2 here. Your goal is to figure out what b is. Hopefully it's not too hard. And I do want someone actually graphing on.
Actually, we're gonna see the graph for the second page. We'll see it for the second page. So you guys can use the
I swear, it'll be a pressure.
So after 1 month, how many yeah, we do that every yeah, and each one following each other. And each one following. Sorry. And then each one following those rabbits have. Yeah. Yeah, so 0. You can shift. So
that's the worst.
We got a mark.
Yeah, yeah.
Hey, we got a big table first.
Why would you waste the matter?
Get you started.
I'm not sure.
Oh, sorry.
You're saying exactly. I'm sorry.
Oh, start to this about it. And then times 2 together.
So it's just like, wow, so I actually wasted such a mistake.
No, actually, you can't work with things. You can't make it fun. That's what I'm saying.
Yes, I can do it. He's yelling.
Well, every pair.
Yeah, so I can. Six, you know, it's potatoes, 1 point. We can be back here in the game. That's completely fine. It's actually. Letting work with that.
No, it's gonna be, you have 6 rabbits, yeah. Each pair has 4, so it's 3 times 4, 12, plus 6. Right. Right. Yeah.
So I should work. I wish you could sign
So month 0. So it seems that on pair. Yeah, it's 18 to 6. You get 3 pairs. 3 pairs.
No, it's fine.
You're so good.
When I was in five, like Michelle would just.
Now you do it quick around hours. Then
I went from my budget.
I'll come back with this. Yeah. So, what pattern that's for part C? It's like, what do we use? It's number. So, month 1 has an idea. So, month 2 we have 2, right? Month 1 we have 6 times 4. Yeah, how many have month? How many have month? My total rabbits, 32. Not quite, 18. Here's the quite. So that's 1 pair, right? 1 pair has 48. So that's why that's 6. Now 6 is 3 pairs. 3 pairs, of course, is 12 babies. So you add 12 more to the 3 pairs. So what pattern does? So y equals 2 times 2.
It's every 2 4 days.
Okay, so make sure you guys can see the pattern for this one.
I don't know.
Yeah, go ahead.
So every month thereafter, each pair rabbit.
Right, so this is,
I got 30. I got 30. Which is 2 plus 4, which is there. There is 6 rabbits.
yes, yeah.
And then each rabbit has 4. But then rabbits, but then those rabbits, each rabbit gets after that.
Each pair has four.
Well, yeah, but there's 6, so,
But that's three
Up there.
pairs. That's three pairs.
right, but each pair has 4.
So 3 times 4 is 12.
Yeah.
And you add 12 to the previous, which is
But-
12 plus 6.
But don't those, like,
So
whatever
whatever
those pairs of, like, don't these pairs of 4s, like, the kids that the original pair had have 4 more?
No, I read kind of, so, then I know what you're saying. Yeah,
Okay, cause it says.
no, you're adding stuff that. So look at it. 0, you had to be right.
Yeah.
So that's one pair, bringing 2 rabbits, one more pair, makes 4 pairs.
Mhm.
So that's of these 6 rabbits, and then we have 6, right? How many pairs? 3 pairs. And they're each gonna produce 4 babies, right?
Yeah.
So that's 12 babies. If these 6 plus 12 more, which 4 stays. That's it. And then if you notice, what are we multiplying? Exactly. So that's how that's what we're counting.
Okay.
So then,
Yeah,
yeah, you can do a quick sketch and then the equations are like.
you get cold and one.
Well, you want to talk fast? Sure. Nice.
No, I don't, I'll look at it, I didn't know the trip, so I don't.
Yeah, I got this. I'm done for the. Yeah, so what pattern do you guys notice with part D now? So part C. Yeah, so maybe that's the other guys. Yeah. Go on.
I did part 2.
What do you have? Yes. Yeah, I'll run the board.
Let's tell you one in this way.
It'll be times 4. Yeah, let me show you guys part D, then we're gonna move on to the next page. And let me just check the timing of things. Okay, cool. Yeah, we got plenty of time. All right. So anyway, yeah, so for part D, make a quick table. You start with 2 rabbits, right? After 1 month, so that's 1 pair. And that pair makes 6 babies, right? So that's 8. Now, 8 is how many pairs, guys?
4.
4 pairs. Each pair makes 6. So that's 24 babies. 8 plus 24 is 32. So what's the pattern here? What am I multiplying by? Times 4, right? So y equals initial value, right, times 4 to the x, right? Okay, cool. All right, we're okay. All right, let's move on to, and by the way, we're gonna need graphing calculators, so get your graphing calculators out. If you guys want to use Desmos, you can if you get a device out. I mean, not a cell phone, but a laptop, that's fine too. Actually, I take it back. I want you guys using a calculator, no Desmos. I take it back. Let's use a calculator. Okay, so get a calculator, or at least have 1 calculator in each table. We're good? Okay, so let's move on to part number 2. Okay, so it says here, your task with your team, try to advise a B to try to find as many different graphs as possible. 6 small values B, for example, less than 10. Use a standard window on your calculator to keep the window negative to 10 with the main range. Decide the team what to advise a B to try so that you may find as many different graphs as possible. blah, blah, blah. Okay, here's what we'll do. I'm going to kind of give you guys some guidance here. Let's do y equals 2 to the x. Let's also do 3 to the x. And let's do 4 to the x. So I'm going to pull up my graph calculator as well and see what happens. There we go. Okay. So you're going to go to y equals. So if you guys remember y equals, right? That's where we pull it up. And let's just type in 2 to the x. Come on, here we go. And by the way, to do an exponent, you have to hit the button right below here. That's the exponent. So we do that. Now, next up, I'm going to do 3 to the x. And next, I'm going to do 4 to the x. Okay. Let me know when you guys got it typed in. We're okay? Okay, it's a graph. Oh, it's so slow. Okay. So I'm going to redraw it. It's just so it looks a little more clear what's happening. Okay, so here is coordinate plane. Here's 1, 1, and 2, 2, 3, 4. Let's color code this. So I'll do red for the first graph. So graph kind of looks like this. There's also 0.24, by the way. Okay. Now, the next one, let's do light blue. They share the same initial value, but at 1 you have 3, and then at 2 it goes out to 9. So it's definitely more steep. So it looks like that. And then the next one I'll do, we'll say orange. I'm sure that's a good color. So X we only have 4, 2 you have it's way high. Okay.
Why do you think it gets steeper as B gets bigger? Because what's happening when B gets bigger? You're multiplying by a bigger number, exactly, right? Now let's think about this too. Let's think about home values. Or actually, for fun, let's do stock values. Give me a company that's done very well over the last 15 years. Google. Great example. I know they changed the ticker symbol, right? Okay. Give me one that may have struggled lately.
Meta.
Okay, I'll took words out of my mouth. Okay, so I'm going to go to Yahoo Finance. That's usually a good place to go. Just kind of give you an example of like real life examples of exponential functions. Finance. It's called, it's still the same ticker symbol. It's just called that alphabet, right? Okay. Let's do max. Okay. Full screen. Try later. Okay. So let's go all the way. There we go. Okay. So I actually remember when they IPO'd. I was fresh out of grad school. Probably should have majored in computer science. Probably should have went to go work in Mountain View and Google. That'd probably be worth billions of dollars now. Just kidding. But there are some people that around here, they're worth lots of money that
work there. So initially the stock was what, like $3, like around this time, 19 years ago, like $4 or $5 was worth. And it did split, by the way. So it means when it splits, it actually you double your shares, right? Depending how they split. But now the adjusted value is about $148. So you see how that's an exponential growth model, right? That's the exponential growth model. Let's say, try and make an equation here. Y equals A times B to the X, okay? X will be number of years since 2004. What year is it now? 2023, right? And what was the initial value? We'll say it's about like $4. What's it worth now? We'll say about $150. And it took 19 years. Now you haven't learned how to solve for B in this case. Your guys are going to learn that skill eventually. But as you imagine, B is going to be a pretty large number, right? Because you're multiplying something over and over and over again. Let's take a look at Meta. Meta's done well, but they had some trouble for a variety of reasons. Let's go Meta. And I do remember when they IPO'd. They IPO'd, I think, in 2011. That bearish means not good. Yeah, so I remember in 2011, actually, I think it was 2012. Yeah. Yeah, I remember I bought my mother like a few $1,000s, and obviously it's worth a lot more now, but we did sell it. But anyway, yeah, June 2012. And then, did all right. And then all of a sudden, it did really, really well. Then it had a dip, right? And it hit a peak. And what do you think happened around this time? Does anyone have an general idea of what may have happened? Well, they did get in some trouble with privacy stuff, right? So there's some of that. Also, they just haven't got creative with their business model, right? I mean, it's like they've, there's more competition. There's TikTok, right? There's other types of social media outlets, but from here to, if you focus on this part, right? Say this is like, what year is this? Yeah, about 2 years ago, right? That's exponential decay, right? So now what happens? So Y equals, the initial value is about like $350. And after 2 years, what is it worth now? Well, at this point, when it went down to how much? Sheesh, like $110, right? Actually, if you were to work this equation out, could someone tell me what 110 divided by 350 is? In their calculator, 110 divided by 350? Point. So sorry, say again?
1.314.
Okay, now let's take the square root of it. What if you take the square root of it? What's the square of 0.314? Do you guys see what a square root button is? Let me get my calculator too. I get 0.56. So what this means is that you multiplied the stock value by 0.56. So you're losing 44% every year because it's going to 56% of its original value. That's not good. You don't want your B value between 0 and 1. You're going to lose money. You want your B value to be bigger than 1 so your money grows, right? So a lot of times when people talk about, oh, I can like get 10% growth in the market or 8% growth, you're usually multiplying by 1 plus a percentage. That's usually what's happening. I mean, that's what B usually equals. It's 1 plus a percentage. Sometimes that percentage is negative. Sometimes it's positive. Positive is a good thing. So you see the market, the analysts don't like Meta. They think Meta is a terrible stock down. I wouldn't buy that stock. Google is bullish because it's on the rise. Why do you think Google's doing so much better than Facebook right now? Anyone have a general idea of why that might what's happening now in our world? And Henry, you have that thought? They do. They're very. But what's kind of the big technology everyone's talking about? You see all the billboard signs in San Francisco.
The internet.
What about the internet? AI. There we go. Google Google and Microsoft are killing it with AI. Facebook's kind of behind a little bit. So that's another reason too. So anyway, there's a story that the data can tell you at times, which is kind of interesting. And these are all exponential models. And apparently, I don't think I own these stocks anymore now. It says these are stocks and falling, but anyway, don't remember which one's which. Intel, no, whatever. So anyway, don't really play the market. Okay, so let's go back to the notes again. So what we want to do is let's now investigate what happens if I make B smaller than 1, right? Let's make B, I'll still do B as 2. So let's do this. We'll go back to our calculator. Let's make Y1 2 to the x power. But let's make Y2 parentheses 1/2 to the x power. And let's make Y3 1/3 raised to the x power. You're going to see a change. So I'll keep that. Let's do parentheses 1 divided by 2 raised to the x power. Next up, let's do 1 divided by 3 raised to the x power. God bless you. Okay, so it's still the same one, but look what's happening to the next one. It swings the other direction. It swings the other direction. And then 1/3 to the x will actually even be a sharper. And it's kind of hard to tell, but if you zoom in, hit enter, zoom in. Okay, there's the first one. Here's the second one. And look at the next one. It's going to be a steeper decline. See how it declines more steeply, right? So when this happens, we call this decay. And we call this growth. Give me a real life example of something that will decay in value. In general, as time passes, it drops. But cars, thank you. Yes, cars. All those cars drop in value. As time passes, as you drive it more. Give me something around here that goes up in value. That you just drive around, you can see houses. Houses go, especially the Bay Area. Houses go up like crazy in the Bay Area. Sometimes it can go down if a lot of people sell, but the Bay Area, for the most part, if the Bay Area goes down, the whole world's gonna fall. So, yeah. So anyway, houses go up like crazy around here. All right. So that's generally what's happening with these functions. Okay. Another thing I want to ask you guys too: how come B can't be 1? What if it would just be 1? It'd just be a horizontal line, exactly, right? What if B were 0? Kind of the same thing, right? Just be 0 the whole time, right? And then the weird thing is, what if B were negative? Say -2, so you're doing -2 raised to the x power. That's just going to jump around a lot. It's going to be really weird. Like if I were to try that right now, that'd be ultra weird. And you have to put in parentheses so that you actually make -2 the base. And it's going to be awfully weird graph if you do that. Raised to the x power. Graph. Yeah, you see it's just a bunch of weird dots. It just kind of freaking doesn't know what to do with it. Even if I go back to the standard window, doesn't even show anything. Yeah, it's just too weird. So anyway, so I'm gonna have you guys do part 3 in your groups, and I'm gonna assign you a B value, and I want you to kind of do a graph, a table, and of course, yeah, just graphing a table. I think that's good. Well, I'm giving the equation. So you're gonna make a table and a graph. So here's what you're gonna investigate. And by investigate, you're gonna do a table. And here's what I want you guys to do. I want you guys to plug in -2, -1, 0, 1, and 2. And your graph's gonna look like this. I'll do the graph over here. 1, 2, -1, -2. Yeah, if you guys do on the poster paper, that'd be good. Yeah, so you guys are gonna do two graphs. Y equals 2tx, y equals 1/2 2dx. Just make a table, make a graph, and
Make sure you guys got it. So you guys can know the poster paper with test markers. They're gonna go. I'm gonna go. Hold on. Yeah, you use the calculator. Yeah, initially. So what we're gonna do is we're gonna graph, we're gonna make a table with all those equations using those X and Y values. And then you're gonna also make a graph.
Write it down.
whiteboard.
I can change it. Oh my God. Okay. Which one?
Yeah. Sure, yeah, that works. Yeah, I'm doing as well, guys. Okay, so
I know you guys are still working. Let's talk about this because bell's gonna ring in 15 minutes. I'll let you guys get this for sure. Okay, so y equals 2 to the x. Oh, am I recording?
yeah, okay.
So guys, y equals 2 to the x. If you were to plug in, it's always a good idea to plug in negative numbers to see what's happening on the left side of the y-axis. So remember, 2 to the -2, that's why I had you guys do this worksheet last week, right? 2 to the -2 is 1/2 squared, which I know is 1/4. So that's a fraction, right? Likewise, if you plug in -1, you get 2 to the -1, which is 1/2, which is 1/2. And of course, the other ones make sense. And I plot the dots there, right? Next up, if I do y equals 1/2 to the x, it's reversed, right? That's decay, because your base value is between 0 and 1. That's decay. So in that case, if I plug in -2, you flip it. If you do 1/2 raised to -2 power, you flip it, it becomes 2 squared, which becomes 4. You got to flip what's inside the parentheses. Now, what happens when you plot those dots? This is dropping, right? Here's the big question, though. Will this curve, this is very important, so you guys get this part. Will this curve go below the x-axis? No. The reason why is that 2 is a positive number. How do you multiply 2 over and over again and make it negative? It's impossible. Likewise with 1/2.
y equals 1 half the x will never go below the x-axis. It gets awfully close to 0. Oops. Gets awfully close to 0, but never below 0, unless if you actually do something called a transformation where you subtract a number. That's a conversation for a later time. So that's really how those graphs will look. Another thing I want to kind of mention to you guys, as x approaches negative infinity, what do you think y is getting closer to as x gets more negative? What number do you think
This scale is getting close to a y. 0, good.
getting closer to 0? And likewise on this side, as x goes towards positive infinity, y is getting close to 0 also. But in this case, as x goes towards positive infinity, as x gets larger, what's y doing? It's just getting bigger, right? And here, as x goes towards negative infinity, what happens to y? That also gets bigger. So these are things we'll investigate down the road, but just to give you an idea of how these graphs are behaving. Okay, so we're going to stop there for today. Let me